Right, Leon, I'm going to try and go through some of these questions for you and explain and hopefully give you a bit of a better understanding of how to do it. So this is the first one I've seen on your pictures. So you have a resistor and then you have two resistors in parallel beside it. So the easiest thing to do is to change these two here. I know my hand's going to be in the way for half of it, but into a parallel circuit so you can, or into series. So you can change, you can redraw the whole thing. You can say this is 64R still, that doesn't change. And then you can call this one RP. RP being parallel circuit. So now instead of parallel and a series together, you have two series. So what you're going to do is find these two first. So in order to do that, the formula is 1 over RP is equal to 1 over R2 plus 1 over R3. I assume you know how to do this, but I'll still write it all out in case you want to go back and try and remember how to do it. So 1 over RP is equal to 1 over 32 plus 1 over 16. So the easiest thing to do is throw that straight into the calculator. 1 over 32 plus 1 over 16 gives you 3 over 32, and then so 1 over RP is equal to 3 over 32. So what you want to do is just turn that upside down. So put it straight back into your calculator, 32 over 3, and then that gives you your RP. So your RP is 10.66 reoccurring. So now you know your RP. So in order to get your RT now, it's just simply a series circuit here, and you can add them together. So it's going to be RT is equal to 64R plus 10.66 R, and RT is equal to 74.66 ohms. Right, so that's probably one part of your question done already. Now the next thing you want to get is IT. So because you have RT, you can get IT. So IT is equal to, and if you can't remember it, you want to draw out your Ohm's law. U is equal to I by R. So because we're looking for I, it's U over R. So U over RT. So U being 48 here from the drawing, 48, divided by RT, which we just found, is 74.66, and that will give you 0.64 amps. Right, so now that we have that much, the next thing you're probably, I don't know, you didn't write out the question, so I'm not sure what's been asked you, but you probably want to find the current in each of these. So the current in a series circuit, the same current goes through both resistors. So the current for R1, so R1 is going to be still 60.64 amps, 0.64 amps. So because you know that in a series circuit the current's the same, so you don't need to go any further with that. Right, now to find the current in this one and this one, you're going to need to find the voltage first in this. Right, so in order to do that, you're going to do U or P, I'm going to call it, is equal to I or P multiplied by RP. Right, so you've already found your amps. So we're going to use them amps, 0.64 multiplied by RP, which we found earlier was 10.66. 10.66, and that's going to give you 0.64 by 10.66 gives you 6.82 volts. Right, so that means your volt drop here is 6.82. So now you can go back and find the currents in these R2 and R3. So in order to find them currents, the easiest way to write it out is I R2 is equal to U RP, which we're just after finding, over R2. Again, if you're not sure, go back to your simple triangle. So you're looking for I, so it's U divided by R. Now, to fill in here. We've already got all our values, it's just a matter of filling them in. So URP, we found it to be 6.82 divided by R2, so we go all the way back to the start, which was 32. And that's going to give us 6.82 divided by 32. 0.21 amps. 21 amps. Right, next we're going to do I for R3. So again, the exact same, use your triangle. All you're doing is changing your value to R3 instead of R2. So it's same thing again. And this time 6.82 divided by 16 is, now see the way the third number is a 6, so we're going to round up. Anything above a 5 we're going to round up, so 0.43 amps. 0.43 amps. Right, so now we have found the current across each of them resistors, which I'd imagine is what the question was asking you, right? So then to check that you're correct, one thing you can do is you can add these two and you should get your IT again. So IT is equal to 0.64. And then these two was 0.21 and 0.43. So IT is I know that they're going to add up, but just to check that you're right, for peace of mind when you're doing your exam, I would go through the trouble of this. Like, you're going to have loads of time, and just bang it into the calculator there or add it up to the variable, and they should add up. And they do. So that's that question complete. You get all your marks or whatever for that. I'll go through the next one now in a sec.